Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about the projections of the oblique lines. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now, an oblique line is the one which happens to be inclined to both the reference planes, that is horizontal plane, as well as the vertical plane. Now, since this line is inclined to both the reference planes, so neither of the front view or the top view, they will be obtained parallel to the XY reference line. So the front view and the top view of the oblique lines, they will always be inclined to HP and VP, right? So here we have got the projections of the oblique line on the horizontal plane. They will be revealing the apparent length of the line in the front view as well as the top view. So we are not going to obtain the true length of the line as projections on HP and VP. Now, due to the inclination of the oblique line with respect to HP and VP, we are going to obtain the horizontal trace as well as the vertical trace corresponding to an oblique line, and these traces should be obtained through the projection lines A dash, B dash and AB, right? So we need to remember this point that the traces, they will always be obtained through the extensions of the projections in elevation, that is A dash, B dash, and the plan, that is AB projection line. Now let us evaluate the problem that we have with us. So the top view of a 70 millimeter long line, it measures 60 millimeter. So it means that the true length of the line, which is PQ, it happens to be 70 millimeter. So we can mark the true length in the front view or the top view as the points P dash, Q1 dash or PQ2 over here. So the true length, which will be P dash, Q1 dash or PQ2, this will be measuring 70 millimeter. And now the top view, it is going to measure 60 millimeters. So we have got the length of the top view. This is the length of the top view, that is the apparent length of a line in the top view, which will be represented as PQ onto the horizontal plane. So this is given to us as 60 millimeter, while the front view of the line, it measures 45 millimeter. So we know that the front view projection we are going to write down as P dash Q dash on the vertical plane. So we have got the length of the front view, that is the apparent length of the line in elevation P dash Q dash. It is equal to 45 millimeter. And another set of information we have got, that is the end P of the line happens to lie in the horizontal plane, while it is lying 10 millimeter in front of the vertical plane. Now with this information available with us regarding the oblique line PQ, now we have to evaluate the projections of the line PQ, inclinations of the true length with respect to horizontal plane as well as the vertical plane, that is the angles theta and phi we need to evaluate. And besides this, we are also required to evaluate or locate the traces, that is horizontal trace and vertical trace of this particular line. So let us start with evaluation of the projections of this oblique line. So here we have got the line PQ, for which true length is available, front view apparent length is available, top view apparent length is available, and the coordinates corresponding to the point P, they are available. Now onto this XY reference line, first of all we are going to mark the coordinate locations corresponding to the first end of the line, that is point P. So we know that point P, it lies on the horizontal plane. So it means that the front view projection P dash will be obtained onto the XY reference line. So distance of point P dash from the XY reference line will be 0 because it is lying in the horizontal plane. Now we know that end P, it is lying 10 millimeter in front of VP. So we are going to mark this distance of 10 millimeter in front of VP below the XY reference line. So here we have got point P located 10 millimeter below this point P dash. Now this distance I am going to mark over here. So the distance of this locus line from the XY reference line happens to be 10 millimeter. So this point P we have drawn below the XY reference line at a distance of 10 millimeter from the XY reference line. Now, having obtained the projections of the point P over here, now we are going to start with this particular aspect. Now we are going to start with the length of the top view projection. We know that this projection PQ, it happens to be 60 millimeter. But usually what we are doing in most of the cases, this projection PQ, this will be inclined with respect to the vertical plane at a certain angle, and this angle name will be given as angle beta, right? So this PQ ultimately we are required to locate onto the plan projection view at an inclination of angle beta. But we also know that the length of this edge PQ is equal to 60 millimeter. So I know that in the rotation of the line problem, even if this edge happens to be inclined with respect to the vertical plane, but ultimately this edge PQ, it is rotated with respect to this particular point P, so that we make this projection line PQ2 or PQ1 parallel to the vertical plane. So here the measurement is available with us, that is PQ. Now once we rotate this PQ, so Q will be available over here. So once we rotate this plan projection line so as to make it parallel to the vertical plane. So I know that in the elevation, so please check, in the elevation I have got P dash Q1 dash point over here. So if I have to obtain true length over here as P dash Q1 dash, so the name of the point corresponding to the plan projection which will be parallel to the vertical plane, this point name will be Q1 over here, because this point I have named as Q1 dash. So if this point is Q1 dash in the front view true length, so the name of the point which will be available with me over here, so this point name will be Q1. So now I have been able to mark the apparent length in plan which is parallel to the vertical plane. Once I obtain this plan projection length parallel to the vertical plane, and then if I draw a vertical projector through this point, so I will be able to obtain the second point of the true length in the elevation view. So what I am going to do, I have got this plan projection edge over here, that is the length of the plan projection or the top view parallel to the vertical plane. So through this point Q1, what I am going to do, I am going to draw a vertical projector line which will be perpendicular to the XY reference line. And once I draw this vertical projector line, I know that I have got 70 millimeter as the true length of the line, and I have already marked this length 70 millimeter as P dash Q1 dash over here. So through this point P dash, I will be marking an arc onto this vertical line. So through this point P dash, I will be marking an arc onto this vertical projector line, so that this distance in the elevation should be evaluated as 70 millimeter. That is P dash and Q1 dash distance I have to mark as 70 millimeter. So the moment I obtain this particular edge length over here, so this edge length P dash Q1 dash, it represents the true length of the line in the front view. And the moment I obtain the true length of the line in the front view, I know that this distance is equal to 70 millimeter. And then I can also evaluate true inclination of this line with respect to the horizontal plane. And this angle we can mark as angle theta. So angle theta has been evaluated. Similarly, true length has been located in the front view projections over here. And we also know that the front view of the line, this measures 45 millimeter. So I have been able to obtain the locus line where my front view projection Q dash will be located, because we know that from the fundamentals of the projections of the lines, point Q dash, which will be the second point of the elevation projection line, and the point Q1 dash, which is the second point of the true length projection line in the front view. Both of these points Q dash and Q1 dash, they will be lying on to the same horizontal line. So I know that the front view P dash Q dash, it measures 45 millimeter. So through point P, so through this point P dash, I am going to mark a distance of 45 millimeter onto this horizontal locus line corresponding to the point Q1 dash. So once I measure this distance, I know that P dash Q dash is equal to 45. So I have marked an arc having the arc length equal to 45 millimeter. So once I have marked this length, so I have drawn this with a black color as usual. So here this P dash Q dash has been marked with black color, and this distance of the apparent length projection in the front view, this is equal to 45 millimeter. So once I obtain this point Q dash over here and have joined P dash Q dash, now I can evaluate the angle of inclination of this apparent length in elevation with respect to the horizontal plane. So this angle works out to be angle alpha over here. So the angle alpha and angle theta, they have been evaluated, and we know that the true length of the line, this is going to be bigger than the apparent length of the line, and the apparent angle of inclination happens to be greater than the true angle of inclination in the elevation over here, that is alpha is greater than angle theta. Now having evaluated the elevation apparent length, that is P dash Q dash, now we can see that this elevation projection line, it happens to be inclined to the XY reference line because the line is an oblique line. Now we have to rotate this elevation projection line in such a way that we should make this elevation projection line P dash Q dash parallel to the horizontal plane, because we know that whenever our elevation projection line, it happens to be parallel to the horizontal plane, so on to the horizontal plane, that is in the top view, we will be able to obtain the true length of this line over here. Now what I have done, I have rotated this elevation apparent length P dash Q dash up to the locus line of the point P dash. So this is my locus line of the point P dash. So once I rotate this line P dash Q dash up to the locus line of the point P dash, so I have been able to obtain P dash Q2 dash. So I have been able to obtain the rotated length of the front view projection, that is P dash Q2 dash. So this P dash Q2 dash, it lies on the horizontal plane. So we can say that this is parallel to the horizontal plane. Now if I draw a projection through this point onto the horizontal plane over here, now I will be able to obtain in the top view the true length of this particular line. So please check, from the point Q2 dash, I am going to draw a vertical projector. So once I draw this vertical projector, now I know that I can locate my true length of the line second point. So second point will be Q2. So Q2 point corresponding to the second point of the plan projection true length, it will be located along this vertical projection line. So from point P, now I am going to mark a distance of 70 millimeter. So I am going to mark an arc such that the arc length should be equal to 70 millimeter, and this arc should be cutting this vertical projector which I had drawn through the point Q2 dash. So wherever there is the intersection of this arc having arc length equal to 70 millimeter with this vertical projector line drawn through the point Q2 dash, I am able to obtain the second point of the true length, that is Q2 over here. So P point is available, Q2 I have been able to locate. The distance between P and Q2 happens to be 70 millimeter. So the true length has been located appropriately in the top view projections over here. Now I can measure the angle phi over here. So angle phi, it is the inclination of the true length of the line in the top view with respect to the vertical plane. So with respect to vertical plane, I am able to obtain the orientation or the inclination of this true length with respect to vertical plane. Now I have obtained this true length as well as the true angle of inclination. Now I know that the projection, that is PQ. So this I can straight away obtain as such over here, because Q dash and Q, they should lie on one vertical line. But what I am going to do over here, I have already obtained PQ1 as the measurement of the length of the top view projection. Initially I had drawn this PQ1 parallel to the vertical plane. Now what I am going to do, with P as the center, Q1 as the radius, now I am going to draw a reverse arc over here, because I know that point Q and Q2, they will be lying on the same horizontal locus line over here. So using this basic fundamental that point Q and Q2, they will be lying on the same horizontal locus line with P as the center and radius is equal to 60 millimeter or PQ1 radius, I will be drawing an arc from Q1 so that I should be able to intersect with this arc the horizontal locus line which I had drawn earlier through the point Q2 over here. So wherever this arc which is drawn in this direction, so the direction also I have indicated. So once I have drawn this arc having radius PQ1 in the reverse direction towards Q2, so wherever this arc is going to intersect this horizontal locus line, I will be obtaining the second point of my plan projection line. So this point name will be point Q over here. And once I obtain this point Q, so I know that this point Q and Q dash, they should be lying in one vertical line. So Q dash and Q, they should lie in one vertical line. And once I am able to obtain Q dash and Q in one vertical line, so it means that I have validated the accuracy of the construction which I have made till now. Now, having obtained the true lengths as well as the apparent lengths in front view as well as in the top view projections, now I will be going for evaluation of the horizontal trace as well as the vertical trace. So let me evaluate the points P dash, Q dash. So they represent the front view elevation projection line. Similarly, points P and Q, they represent the plan projection line projections in the top view. Now, P dash and Q dash line, this line, it is going to intersect the XY reference line at the point P dash. So here I am going to locate the point H dash over here, because here the front view elevation line itself intersects with the XY reference line. So here I am able to obtain the point H dash. From H dash, if I draw a vertical projector, it is going to intersect the plan projection line PQ at the point P. So at the point P, that is point H and point P, they are going to coincide with each other. So my horizontal trace corresponding to this oblique line will be equal to the distance H dash and H over here, which happens to be 10 millimeter. So we can say that the horizontal trace of this line happens to be 10 millimeter. Similarly, now let us evaluate the vertical trace. Does the plan projection line PQ intersect with the XY reference line? Answer is no. So if it does not intersect, that is PQ does not intersect with the XY reference line, I need to carry out the extension of this black line or the plan projection line PQ. Now once I extend this line, so the point of intersection of this extended plan projection line with the XY reference line will give me the location of the point V. Now from point V, I have to obtain a vertical projector line in such a way that it should be intersecting with the elevation projection line P dash Q dash itself or its extension, because if I draw a vertical projector line, it is not going to intersect with the elevation projection line P dash Q dash itself. So what I have done, I have carried out the extension of the elevation projection line P dash Q dash. Now once I have extended the elevation projection line, now I will be drawing the vertical perpendicular from this point V so that it should be intersecting with the elevation projection line itself or its extension. So wherever it intersects with the extension of the elevation projection line, that is P dash Q dash, I'll be obtaining the point V dash over here. Now, once I measure this vertical projection distance over here between points V and V dash, so this will provide me the measurement of the vertical trace of the line. So this is the vertical trace of the line. And another thing we can verify, points P dash, Q dash, H dash and V dash, they will lie alongside one projection line. Similarly, points P, Q and H and V, so they will also be lying alongside one projection line. So with this, we have been able to evaluate the true lengths of the lines, their orientations in the front view as well as in the top view. Similarly, we have been able to locate the projections of the line P dash, Q dash and PQ in the front view as well as the top view respectively. And their orientations, they have been also established with respect to horizontal plane as well as the vertical plane. And finally, we have also evaluated the horizontal trace as well as the vertical trace of this oblique line. This is the discussion regarding the evaluation of the projections of the oblique line as well as the true length of the line in the front view as well as in the top view. And we have also been able to obtain the traces of the line. So this is all for today. So we'll be continuing with further illustrations regarding few more cases of the projections of the oblique lines in the coming lectures. So thank you very much. Thanks a lot.